Hi there. So in this video, we're going to be talking about how to get started working with images in Python. So for anyone who might want to load in images, do some cropping, cutting, and general operations, if you're not familiar with what the library is that you need to use and the commands to get started with that, then this video is going to be for you. So in these particular videos, I will be using Anaconda to get started. So if you're not familiar with Anaconda or you're not sure how to install it, there's a video on my channel that shows you the steps in order to do that, which I'll include the link to that video down below in the video description. So the first thing that we're gonna have to do is install the library for Python in order to use images. So what I'm gonna do here is I'm gonna launch the command prompt for my Anaconda Navigator, and it's going to pop open a window like this. And once that's done, all you're going to have to do is type in the following command: conda install-y pyopencv. So I already have it installed on my system, but you're going to enter this and it should run through the whole works of getting you set up. And once that's done, go ahead and launch Jupyter Notebook and we can get started with the next steps. So over here you can see a couple of cat images that I have, and for this particular example I want to load this image right here, this cat.3.jpg, and I want to load it into Python and display it in Python. So how do we go about doing that? Well, let's take a look over here and open up this notebook that I just created. So I happen to know where the data is located over here under samples. So just to let you know, full disclosure. So the first thing we need to do is import the library that we just installed. So it's going to be import cv2, that's what it's referred to as. And the next step is to import numpy as np, because cv2 handles all of its data as numpy arrays. And that's pretty much it. After that, we can go ahead and get started. So in order to read in the image, I'm going to use a command called imread, but first we need to create a variable to store this. So I'm going to call this cat image and cv2 imread, and I need to specify the full path of the cat image. So let's take a look over here. It's data sample cat.3.jpg. So you would obviously be using your own path in this situation. So let's just check out the type. And we can see that it is indeed a numpy array. And let's also check out the shape of this numpy array. So one thing that I want to specify over here is that it's 414, 503. What does that mean? It means that this is 414 pixels in the y direction, vertical, 500 pixels in horizontal, x, and 3 color channels. So that means that we have 3 separate 414 by 500 pixel arrays or matrices, which are each represented by the color channel. So each color channel is, since there's 1, 2, 3 for each one, this one would be BGR, which is, hold on, let me put these as comments. BGR, which means it's blue, green, and red. So normally people would expect it to be something like RGB, since that's the usual thing, but cv2 is special, okay? It's very special, and you should recognize that it's special, and they do BGR for whatever reason. So just get used to it and accept it, embrace it. All right, so next things next, we got to figure out how we're going to, we have the image loaded over here, but how exactly do I go about seeing the image to verify that it's the correct cat image? I don't want to load some image that I think is a cat image and end up with a picture of an onion or something. So let's go ahead and check that out. What you need to do is run this command, cv2 imshow, and what you're going to type in here is the window name. So and I'm just going to call it window name just so you know what I'm talking about, and the image, which is called cat image in this case, since I loaded it over here as cat image. Now, normally you could just run this, but CV2 is kind of nitpicky. You actually need to also type some additional commands over here. So just follow along with me, cv2.waitKey and cv2.destroy all windows. And what this does is cv2 IamShowCatImage, it basically runs and it won't display it unless you type in this command, because you need to give it sort of a halt. And after you give it a halt, this is basically the command to clear out the cat image window so it doesn't just say lingering forever. So I'm gonna go ahead and hit Shift Enter and run it, and I'll show you guys over here what I see. So that is indeed my cat picture, as far as I can tell. And you can see the window over here, it's called window name. That's where it got this name over here, and it's the cat image. And if I hit the enter button or the space key, or any key for that matter, it will then step down to the next command over here, which is destroy all windows. This seems kind of annoying though, to type all these 3 lines every time you want to, display an image. So what I normally do is I'll just write a function that does it for me. So I'll write this as disp image define, and we're going to get the window name and the image that we want to have displayed. And you could just essentially write the same thing that I showed over here. IamShow window name image cv2 waitKey 0, and then cv2. And in this case, instead of destroy all windows, I will do destroy window and specify window name as the target. And we're gonna go ahead and run that, and let's test this out. Disp image, we're gonna give it the name cat window, and we're gonna use the cat image again. And we can see over here, it did pop up. I'm gonna hit the enter key and it will automatically close. That's great. Okay, so the next thing I wanna cover is talking about the color channels. So as I mentioned earlier, the image here has 3 different levels on its 3rd dimension, which each one is represented by a color channel. So the 0th one is blue, this level 1 is green, and level 2 is red. So if I wanted to take each one out, let's call this blue is equal to cat image 0, green is equal to cat image 1st level, and then red is equal to cat image 2. So if I wanted to display all of them together, let me just combine them by making all colors equals p.hstack. And what hstack does is it horizontally concatenates each of these arrays together into a single array. So this way I can just now use my command. Let's call it all and all colors. Now let's run this and see what we get over here. So this is the image that I have, and one thing that you'll notice, they might all look the same, but actually if you look a little bit closer, you can see that there's very minute details, like this cat over here, its nose looks a little bit more white than this cat, and this cat over here, its eyes are a little bit more darker than the other 2 cats, right? So actually these all look like they're grayscale colors, but they're actually their own respective color channels. So what if I wanted to see the color channels themselves? Well, one way I could do that is let's call blue again, and we're going to call it cat np.copy. So copy just makes a copy of the image, and copy cat image, and I'm going to set the other channels to 2. So in this case over here, where I assign blue to equal the 0th level of the cat image, this is actually, I'll show you over here, blue.shape. Oh, whoops, I gotta close this image. Yeah, you can see that it's a single dimension. So because it's a single dimension and it doesn't have 3 different levels, CV2 treats this as a black and white image. So everything is just on a black and white color channel. But if I wanted it to be displayed as actual blue, one way you'd have to do that is to copy all three levels. So we can see over here, blue.shape, and we do have the three levels, and I'm just gonna go ahead and set each level to 0, except for the blue channel. So in this case, the blue channel is 0, so I'm gonna set the green channel to 0, and I'm gonna set the red channel to 0 as well. Now let's do disp image. Well, you know what? Let's go ahead and do that with the other colors as well. Green is equal to np copy cat image, and then green, set the blue channel to 0, and set the typo, and set the red channel to 0 as well. And then finally we'll do red equals np copy cat image red, set the blue to 0, which is indicated by level 0, and we're going to set the green also to 0. Whoops. Now we're going to do a hstack, all colors again, equals np.hstack, and it needs to be a tuple, so blue, green, red. And then disp image, which is the command that I wrote earlier, all colors. Now let's see what we get now. Okay, and this looks a little bit more reasonable. You can see that this is the blue, this is the green, and this is the red, just as I stacked up over here. And one thing that's interesting is that out of all three of these pictures, which one do you think looks the most clear? Which one's the easiest for you to make out? It's usually the green channel, and the green channel, for that reason, it has the answer to that is kind of interesting, because human biology, in terms of our eyes, we are the most sensitive to green color, so we pick up on green the best, and blue and red are not quite as good. So due to that fact, cameras, when they capture images, they tend to have a lot of detail on the green aspect, because our sensitivity to green light is about double that to blue and red. So you'll notice here now, instead of the grayscale, when we're looking at it with the actual colors involved, you can definitely see that this is the most high definition color. And because of that reason, usually when you're getting a picture and converting it to grayscale, what the computer just does is it just copies the green channel because it has the most detail, and it just makes it one dimension. So usually when you're getting a grayscale image, it's just the green channel, and that's just a trick that you can do in the future. If you wanted to convert a picture to grayscale, all you'd have to do is just copy this one channel and flatten it to a 1D image, and that would be it. So the next thing I want to talk about is cropping an image. So here I have the actual cat image open with a program called IrfanView, and let's say I wanted to crop out the cat's head itself, like just this whole section right here. How exactly would I go about doing that? So we can see that on my selection area up here, it says selection 5.6, and in IrfanView it's XY, so it's one thing to keep in mind is that, remember, CV2 is YX, so these two should be reversed, but the starting point is 5.6 XY, and then the dimension of the picture is 232 by 200. So you just add the 5 to this and the 6 to that, and that gives you the 2 points. So in this case, it would be 5, 6, and the ending point would be 5 plus 232, which is 237, and 6 plus 200, so it would be 206. So our starting point is 5.6, the ending point is 232. So in order to get the cat head, what we need to do is we can just specify that area of the image. So we can do cat image, and we're going to say, since it's YX, we're going to do 6 to 206 and 5 to 237. And we want all the channels, so we're just going to do a colon there, so it's going to give us all the channels. Now let's do disp image cat head and cat head. Let's see what we get. And whoops, I gotta turn this off. There we go. So there you go. This is the cat head, and just like we expected, we were able to crop it out. Okay, so the last and final trick that I want to show you guys is how to get the negative of an image. So what do I mean by negative? It would be flipping all the colors upside down essentially. And the reason I want to show you this is because of the fact that I kind of want to just demonstrate to you guys, how CV2 views colors, like the value representation. So if we take cat image over here, and let's say we do all the channels, but I just want to see the blue channel. You see these numbers, right? And each of these numbers represents a pixel of value between 0 to 255. So that means that the highest value, the most blue you can have on this blue channel for this pixel is 255, and the least is 0. So you have 0 would mean that you have no blue at all. And if you have 0 on all 3 of your channels, then that's just black. And if you have 255 on all 3 of your channels, then that's white. So flipping the image upside down, we could call this grumpy cat instead of negative cat. CV2 bitwise not, and let's call it cat image, right? And let's see what we get when we just image the grumpy cat. And let me drag this over here. And that's what it looks like over there. So that should kind of make sense if you look at the original image. You can see like, hey, the white turns into black, the black turns into white, and these green colors kind of turn into the opposite. It's like opposite land, basically, what happens here. And let me demonstrate. If we go over to Grumpy Cat, and we do the same thing with what I did earlier, and we took a look at the blue channel. Oh, I gotta close this, of course. You can see over here that the first value is 142, this value is 133, and I'm only showing you one channel, mind you. What the bitwise not does is it does this for all 3 of the channels, but 142, 133, how does it come up with the 113? So 142 plus 113, it equals 255, right? Great. So what actually ends up happening is, when you do a bitwise not, what this does is it subtracts 255 from every value in this array and takes the absolute value and returns this. This is what you're getting. So I just wanted to show you this example so that you guys can understand what these numbers actually mean between 0 and 255 when you're working with CV2. So that's pretty much it for this video. I just wanted to cover a very brief introduction to get you familiar with how to install CV2, how to read in images, and how to, manipulate and work with the images and what exactly these arrays are representing. So in addition to all of the stuff that I covered, anything more advanced such as, line detection or edge detection, like figuring out shapes or recognizing objects like stop signs and things of that nature. That's all stuff that I figured I'd save for another video since it does get a lot more involved. But if you thought this video was helpful, then please leave a like and subscribe to the channel as well. And also please leave a comment on what your thoughts are and what else you would like to see me create next for the video. I'd be more than happy to provide you guys with that content.